Hey Team 6-1, before you start this, you will need the packet that should be beside the door where you usually pick up your Do Now or Bell Work, and you will also need your interactive notebook and a pencil or something to write with. Okay. Obviously, this is about potential and kinetic energy. I'm using a PowerPoint that I bought from Kessler Science, so I wanted to give them credit. Today we're going to go over comparing and contrasting potential and kinetic energy. So again, hopefully by the end of this you will have a better understanding of potential and kinetic energy. Alright, starting on the front page of the packet, we're going to take some notes, so feel free to pause as you need to. So potential and kinetic energy. First of all, energy is the ability to do work. It is the ability to move or cause a change in matter. And if you didn't know, everything in the world is made of matter. And of course, there are two types of mechanical energy. You're going to see that word again later on, probably next week, mechanical energy. So the two types are potential, which is stored. You'll probably need to write that down on your paper. And kinetic, which is moving. I need you then to switch to the interactive notebook page. That is the Venn diagram. I think it's the third page of the packet. And you're going to write on that for a little while. Okay? So what is potential energy? Potential energy, you're going to write this down over on the left-hand side of the circle. It's stored energy in an object due to position, meaning where is it at in comparison to the Earth. It is ready to be used, but it is not being used. Makes sense, right? Because it's stored. All right, see how this next is in red? This you are going to write in the center because as we'll learn here in just a few minutes that it is also a part of kinetic energy. So this is for both. They can both be transformed into other types of energy. So you have to only write it one time in the center there. Same thing. When we measure energy, it's usually measured in joules. I believe that's how it's pronounced. All right, back to just the potential. Distance or height and mass determine its measure. And as we've been talking about, the higher an object is placed, the greater gravitational potential energy. And so we're going to get into the mass of an object. And you see that red print again, so where does it go? In the center. It is found, potential energy is found in all objects. Okay. We're going to go back to the front page notes. So which ball has the greater potential energy? Well, we're talking about gravitational potential energy, and the amount of potential energy is determined by its height and its mass. So here, they are both the same mass, same size, but A is higher, so A is going to have the greater gravitational potential energy. Because the higher an object, the greater its potential energy. Again, these are some notes for the front page. All right, something else we need to know. The greater the mass, the greater the potential energy. So which ball has the greatest potential energy? Even though they are at the same height, A is bigger. So A has the greater mass and is going to have a greater potential energy. All right, you need to flip back to your Venn diagram, and this time we're going to take a look at the kinetic energy side, so on the right-hand side. Kinetic energy, obviously, is the energy of motion. It's formed or caused by motion. Again, you should be writing this on the right-hand side. Feel free to pause because I know I'm going fast. All right, you should have already written this, but kinetic energy can also be transformed into other types of energy. And it's also measured in the joules. Okay, this is different, so it's going to go back under the right hand, like half moon. Speed and velocity, and we'll talk about those as we move forward, and mass determine its measure. And again, you should have already written it's found in all objects, just like potential energy. So now you should be done with the Venn diagram. I'm going to go back to the front page notes. Here we're talking about kinetic energy, so ball A on top is bouncing at, its height is 20 meters, and ball B was bounced at 10 meters. So which one would have more kinetic energy? The amount of kinetic energy is determined by its speed and velocity and its mass. Well, they both have the same mass, and so the one that has the greater speed or velocity. So ball A, which is 20 meters, is going to have the greater kinetic energy. The faster an object moves, the greater its kinetic energy. So again, which one has the greatest speed? A. All right, the greater the mass, the greater the kinetic energy. So again, the bigger it is, the more gravitational pull it's going to have, and the bigger it is, the faster it's going to go. So which ball has the greatest kinetic energy? That's right, ball A. If you flip that page over, actually, now that I'm looking at it, this is actually on the bottom. So it's not page 2 notes, it's on the bottom of page 1. Sorry about that. Transformation of energy. So a bouncing ball, several energy transformations happen when a ball is dropped on a surface and bounces up again. So that first ball, it's at its highest. Okay, we've already started it bouncing, so it has bounced up and now it's ready to come back down. It has a maximum potential energy and no kinetic, because there's a split second when it's about ready to drop back down. That second picture on your paper is where it's moving, and so the potential energy is decreasing and the kinetic energy is increasing. So that's the transformation. We would talk in class like that's probably like a 50-50. And then once it hits, now it doesn't have any potential energy because there's no gravitational pull on it anymore, but the kinetic energy is at a maximum. Again, when it bounces back up, and if you can see in the picture, these two balls are right at the same size, same height, and so we are back to the potential energy being a maximum and the kinetic being none. All right. This is now the second page. This is a transformation of energy, and we have a pendulum. A pendulum is like a ball that swings back and forth, or a bob, they call it. So several energy transformations take place as the pendulum bob swings. So at point A, the potential energy is at a maximum because it's at the highest point that it would go. The kinetic energy is at a minimum because, again, there's a split second where it's not moving because it has gone to its greatest height and it's going to get ready to swing back downward. B then is where kinetic energy is at a maximum because it's speeding right along, and the potential energy is at a minimum because it's now the height has changed in that bob. And then as it swings back up, it's going to go back and see C and A are at the same height again. And so we're back to the potential energy being a maximum and the kinetic energy being a minimum. Because again, it's going to swing up and then it's going to pause for just a split second as it gets ready to come back down. Underneath that we have a roller coaster, and if you were in class yesterday, you would have seen this picture. So I want you to be careful because on the labeling that I have on my on the paper, it's different than what you see here, okay? Because kinetic energy is on top, is listed on top every time, while I have potential energy listed on top every time. So the person in the roller coaster at the very top hill, in the first one, that's the highest potential energy, gravitational potential energy. It's going to be at 100%, and the kinetic energy is going to be at 0. And then the roller coaster is going to go down, and about halfway down, they're both going to be 50-50. And then at the bottom of the hill, there's 0 potential energy because it is at ground level again, and 100% kinetic. And as you see, the roller coaster is going to keep on going, but this next hill isn't as high as the first hill, and so we have to kind of balance that out. So the kinetic energy, it's moving really fast, is 75, and the potential is 25. And again, remember, I have those switched on the paper, so make sure you get them labeled correctly in the correct spots. All right, now you're going to skip to the 4th, 5th, and 6th page of the packet. You're going to cut out these 3 templates, and then you're going to glue the bottom one, as it's labeled, into your interactive notebook on page 40. So if you need to, just label up until page 40. And so you will glue that on page 40. You're going to glue the middle one along the tab, just along the tab. It will be turned upside down, okay? And it's going to flip up so that you can be working and seen while working on sheet 2. Okay, and then we have the top. And I have a picture if you're confused about this, okay? It's going to look like this. Okay, so the middle page is closest towards you, and the first page, or the top page, is furthest away from you, and then the roller coaster you're going to cut and you're going to put that in the middle. And then the roller coaster will kind of fold down onto that bottom page. Okay, so let's take a look at that. As you can see, at point A, it's mostly potential energy, and at point B, it is the losing potential and gaining kinetic. Point C, it's mostly kinetic. And then at point D, it's losing kinetic and gaining potential. So you want to, again, make sure that you fill that out before you go on. This is just another visual. So we have the roller coaster on the right-hand side, and the yellow is at the top of the hill. And so it's the greatest amount of potential energy, 0 kinetic. And then it goes down the hill, so the orange is the 100% kinetic and 0 potential. It does this little hill, and then it's going to do a loop. And in the loop, as the ball is going up, look at the top graph. So the potential energy is going up and the kinetic energy is going down. Okay? That's the light blue ball. And then the purple one, as it comes back down around the loop, then it's going to lose potential energy because it's getting closer to the ground. And it's gaining kinetic because, again, it's speeding up. All right, so this is just a real quick check. Decide if each situation is an example of kinetic or potential. Standing on the end of the diving board. You're waiting to dive in. That's potential. Falling from the top of a ladder. You are actually moving, so this is kinetic. A rubber band pulled back as far as it can go. This is potential because you are putting that stored energy in there. Water in a lake behind a dam. It's blocked, and so it can't be moving, so it's stored. So that is potential. Baseball just before it is released by the pitcher. that is also potential, because he's going to let it go and it's going to fly, and then once he lets it go, that's kinetic. All right, you're going to go to the last 2 pages of your packet, and you're going to cut out these little scenarios and make some pockets. So there are 8 situation cards, and you need to figure out if they should go into the mostly potential energy or the mostly kinetic energy. And we'll be checking those in class. Okay, so take some time. You're also going to glue your Venn diagram into your interactive notebook. You can do that on like page 42 or something like that. I'm not sure how it's going to work out for you. Okay, and see how the pockets, you have to kind of fold them underneath where it says to glue, and you have to fold on the dotted, cut on the solid, just like what we've been doing with our roller coasters. Okay. All right, last step. If you've gotten this far, for I don't know, maybe you can bring me your paper, and I will give you some candy or something like that. We can come up with something exciting to you for fun. Can you compare and contrast potential and kinetic energy? So when you compare something, you're telling what's the same, and when you can contrast something, you're telling what's different. So if you just write a little note, it would probably be at least 2 sentences, but if you can make it longer, that's even better. And then you can see your teacher for next instruction. All right, and hey, it's been a while since I made a video, so don't forget, go Hawks!